but not impossible. So let's get those calculators ready to go, and let's see if we can kind of put this together. I'm going to add a little wrinkle to this, and wrinkle's the wrong word. I'm going to try helping some of you who are having difficulty. If you had come to last night's kind of trig help night, you'll find that we did this a little different than using your calculator. We used so question number 2 says that a plane has to be traveling at 75 meters per second to land in a crosswind blowing at 25 meters per second, 50 degrees north of west. If the runway is due north, what direction should the plane point in order to successfully land? And how fast will the plane be traveling? One way in which these problems are different is that we're not adding together two vectors in the same way because we don't know the angle of one of the vectors. We're told that the plane is going to be, having to land on this runway, and that the runway is, in this case, due north. So, although we don't know the size of the final vector, we know that the plane has to have its final vector only be in the north direction. So that gives us some clues as to what we have to do. One of the things we have to do different here is we kind of have to make a prediction of what we think the plane must be doing in order to make this landing. We're told that the wind is 50 degrees north of, is it north of west? Yeah, north of west. So the wind looks something like that, 50 degrees, and it's 25 meters per second. Now, without doing any operation on the wind and just looking at that picture, it's pretty clear to me that the wind is going to blow the plane off course to the left, in the west direction. If you're the plane and you want to land on this runway, your choices are limited. You either fly somewhere in this direction, in this quadrant, or in this quadrant. Which of these is most likely to allow you to travel down the runway? I'm thinking quadrant 1. You guys agree with me? So we need to have a component of the velocity that counters the components of the velocity for the wind. So I have a negative x component for the wind. I'm going to need a positive x component for the plane. So as just a quick sketch, I think my plane's going to be somewhere over there, with this being 75 meters per second. And it doesn't matter to me whether you measure your angle from the y-axis or from the x-axis. You just need to pick one and be consistent. For the way in which I've drawn this, I'm going to go ahead and say from the x-axis and use that as my theta. Now, I know I don't have the angle, but that's all right. What we're going to do now is the problem, the way in which we've been doing them so far. We're still going to break our vectors up into two separate problems and convert them from polar to rectangular. One of them is the wind, and we have everything we need to know about the wind to do that. So let's do the wind first, and then after we do the wind, we'll do the plane. And even though we don't have everything about the plane, that doesn't mean we can't come up with an expression for the plane's components. Now, that word expression seems to be lost on some folks. An expression is just an equation with variables in it. So we're going to create an expression that has some unknowns. Hopefully, there'll be a way for us to solve for those unknowns. So, the wind first. Something like that, 25 and 50 degrees. All right. So, my set of steps to take this vector and convert it into components isn't any different than before. I'm still going to wrap a triangle around the angle, like so. I'm going to take a look at this triangle and recognize that this is the opposite side and this is the adjacent side. I'm reaching a point where I don't want to write out sine 50 equals opposite over 25. I just kind of want to say opposite equals 25 sine 50. But don't let me stop you from still saying, okay, cosine 50 is adjacent over 25. So adjacent equals 25 cosine 50. If you like writing them out and it makes you feel a little more comfortable, do so. But don't combine it together incorrectly. You're not going to get any points if you do your algebra wrong. What was that? So, before I move on from here, be cognizant of what's negative and what's positive. So, 25 sine 50 is easy. That's 12 and a half. 25 cosine 50 is probably like 21 or 22. Is that right? Maybe 21.7, I think. So x and y, the adjacent, 25 cosine 50 is going to be in the x direction, and it's negative. And that's the one that's going to be 21.7 x hat. The other part of the wind, the opposite side, is 25 sine 50.
Are you using the trig chart to get these numbers?
No, I think I'm just thinking of the one I did last class period, which was 30 degrees, because I'm not even close. So, sorry, Mr. Shelton's not even close. Let's grab that trig chart. I have no idea what those two numbers are, but I'm sure one of you can tell me. So what's 25 times 0.766? So 19 point what? That's in the y hat direction. And 25 times 0.643? 16.07. And it has to be negative. We good? All right. Now, that's the wind. We now have to do the plane. But again, we don't have an angle for the plane. That doesn't mean we can't kind of estimate. Plane's going to be over there somewhere. It's going to have a length of 75, but the angle is unknown. I'm still going to wrap a triangle around the angle. I'm still going to assign opposite and adjacent. I'm still going to consider what the ratios are and say that sine of theta is equal to opposite over 75. Cosine theta is equal to adjacent over 75. So the opposite, 75 sine theta, adjacent, 75 cosine theta. These are expressions. They don't have an answer, but they still will help us figure out what direction the plane has to point. So I'm going to take my expressions and place them where they go. The adjacent appears to be along the x-axis, so that's 75 cosine theta x hat, and it's in the positive direction. And then plus 75 sine theta in the y hat direction. So, oh, maybe they stole the soap. And so here we go. So it's at this moment that you have to decide how do you progress from here. And let's just be really clear here. The only way the plane safely makes it along the runway is if the x component is 0 when we add them together. So when I'm looking at the sum here, I need a resultant where the x component is 0. The y component, well, that's going to be the actual ground speed. but I'm choosing an angle where the plane's x velocity cancels out the wind's x velocity. That's what we're looking for. What angle will make that happen? Now, this problem is actually more straightforward than question number 1. But in doing this, what we have to do is just add those together, minus 16.07 plus 75 cosine theta, and set it equal to 0. There's no doubt this is probably going to give us the right answer. But be aware, there's what we call the null answer as a possibility too. And you guys tend to not write down all the things, so keep this in mind as I'm solving this for theta. Before I go any further, look closely here. If this number is greater than 1, then there is no cosine. Right, there's no angle whose cosine can be greater than 1. Cosine goes between 0 and 1. So if this number is greater than 1, the plane can't make the landing. There's no direction it can face where it can cancel out the wind's component of the velocity. So don't think of that as I did something wrong or the world is broken. No, there is no answer. That is your answer. There's no angle where the plane can safely make the landing. In the same regards, look over here. The plane has to have a positive velocity as its answer. The only way the plane makes it across that runway is if it's traveling in the positive y direction. If you work this out and your ground speed ends up being negative, that says to you, again, that the plane actually is not going to be able to land safely. That at the angle you've chosen, the plane's going the wrong way with the wind's contribution. So there are null answers that have meaning, and you'll have to know that. Now this one, not really a possibility, but in problem number 1, because the wind is facing against the runway, it's possible to find an angle where you can line up with the runway, but the wind be powerful enough to push you backwards and not allow you to land. So don't just throw away null responses. They have meaning. I'm assuming that at this point, there's people here who know what this angle needs to be. And when I did this, I think I got like 77 degrees or something close to that. So 70. So 71. 78. Thank you. I can hear you, but I can't hear all of you at once, so I try. That's actually not the answer. I do need to say it's 78 degrees north of east. You still have to provide the reference. It was here. So this is the direction the plane has to face in order for it to land successfully. Now, we're not actually done. This gave us the heading of the plane. To get the ground speed, we need the resultant vector, because the resultant is still the ground speed of the plane. It is the plane's progress along the ground. So that's still this sum, the part that's left. So 19.15 plus 75 sine 78 degrees. This is the ground speed of the plane. I don't know what that is, but I'm sure you guys can figure that one out. All right. Now, I would say 92 north. We fashioned it to be due north, but you should always say ground speed plus its direction. So it's not much different than what you had to do before when you were adding vectors, but it's different. It's enough different. Yes, sir.
For the number 2, what did it say the constant airspeed was?
It says the crosswind is blowing at 25 meters per second, 50 degrees north of west.
Does it mention like a speed that the plane has to be?
A plane has to be traveling 75 meters per second to land.
Alright, that's all.
Yeah. Now, question number 1 is exactly like this. If you haven't attempted the homework, you should attempt number 1. You are going to get a question like number 1 or number 2 tomorrow as a quiz. So I've now... All right, are we all in agreement that the plane has to have a velocity either this way or that way? That's the only 2 possibilities, and one of these is very much less likely than the other. All right, can we probably all say no to this one? All right, that's good news. So it sounds like we all kind of have an understanding that the plane's going to have to be going this way somewhere. That's a good start. Did you figure out what the wind's doing first? Probably a good idea. Do we do that first? Yep.
Are you gonna, here's tomorrow, whether we use like the angle that you have on here, like a complementary angle?
I am not going to care. So you guys who are still working on it, those are our rectangulars, right? Got the opposites and adjacents kind of lined up. So did you guys line them up on the chart correctly? Your X and your Y's, did you put your negative signs where they need to go? We good to move on? We seeing where we are? I'm okay. because this is the one I'm going to set to 0 because I want to have no x velocity. I want to only have a y velocity. That'll get us there. All right. We are out of time. So solving this for theta, I get cosine theta equals 13 divided by 50. And so theta is going to be 75 degrees. So that's close, but this is where theta is. So what I really mean is 75 degrees south of east. Now, with that done, I can kind of figure out the ground speed. That's going to be right here. Negative 50 sine 75 plus 7.5 is going to equal ground speed. So you need to take the sine of that 75 and multiply by 50. And then I'm going to be subtracting that from 7.5. It looks like this gives us negative 40.8 meters per second. Now, that's the ground speed, and it's negative, which is important because we need it to be negative, so we're traveling in a negative direction as we travel down the runway. A trig chart, if you've never used a trig chart before, it's just another way of doing the trig. It replaces using the sine, cosine, and tangent button on your calculator is all it does. But trust me, the sine, cosine, and tangent button tends to be where you make mistakes, silly mistakes, especially people who are novices or who fully don't appreciate what it is they're trying to do with their calculator. So in today's discussion, I'm going to refer to the trig table instead of having you guys execute sine, cosine, and tangent on your calculator. But you're welcome to use whatever means you wish to get the answer. I'm just trying to provide you another resource. This was sent to you guys as an announcement last night. You're welcome to have this out on the next test if you prefer to use a trig chart. A trig chart is provided on the AP exam for any angles that are going to be used on the exam. It's built into your equation sheet. Generally, they give the values for 30, 60, and 45, which tends to be the angles they use if they're going to do a numerical angle. Let's see. All right, so I need to find 50 degrees. There she is. And from here, the sine is 0.766, and the cosine is 0.643.